Hello, my name is Hannah Cloke and I'm a hydrologist, which means I study rivers and floods. But I'm also a fortune teller. I can predict the future. I can see things that have not yet happened. And if you like, I'll take you on a journey through time into the future, but also back into the past. I'm going to show you why I love rivers so much and how I became a flood scientist. I'll show you how scientists know where all the water in the world is going to go, days and weeks and years in advance, and how that knowledge can be used to save lives. And I'll show you how predicting the biggest of floods means we have to understand the behaviour of the tiniest molecules. And if that sounds a bit confusing, don't worry. Chaos and confusion are also a big part of the story. And understanding how things get chaotic is one of the ways we make sense of what will happen next. Right now, I predict that if you stay with me, you'll know a bit more about it in a few minutes' time. First of all, I want to take you back in time and introduce you to a little girl, me, aged 9 years old. Every summer, I went on holiday with my family to see my grandparents in Devon on the south coast of England, and water always played a big part. If you think about your family holidays, maybe it played a big role for you too. There are the days looking out the window at the rain, miserable that you can't go outside. There are the trips to the beach and swimming in the sea. And there's paddling in rivers and ponds. I absolutely loved that. Maybe I just never grew out of it. I remember feeling the current moving through the water and the patterns of the ripples on the surface. How the temperature changed from warm to freezing cold at different depths, and how the riverbed got deeper and changed shape as you moved from one bank to the other. I remember spending many a happy week swimming in Dartmoor rivers, collecting pebbles and digging and diverting intricate channels on sandy beaches. This fascination stayed with me through school and university, and while I didn't know it at the time, it helped lead me to a career as a floods researcher. I think you have to spend time really looking at something to understand it, and I don't just mean with your eyes. It's much more important to use your imagination. To this day, often I just stand by rivers, almost mesmerised by the water. I love watching the flow of the water and thinking about all the many, many droplets that are passing by me right now. Where did each one of them come from? Which pathway through the landscape did they take? When did each drop fall as rain? It can seem like an impossible task to try and understand the flow of a river. So sometimes I like to imagine that I have superpowers and that I can see every single droplet. I imagine that I can see each droplet clearly as individual blue pebbles, like these ones. Each droplet has its own history and destiny, and I can see them all, read them all, follow them all. So let's slow down time, stop it, and zoom in until we can see each of the individual droplets of water. We'd see that each droplet is unique and has its own history. And then let's rewind time even further and follow each droplet back to its source. What's the story of each drop? Maybe this one fell in some really heavy rain yesterday in a street and rushed over the land straight into the river. Perhaps this one fell last year and has been sitting in the soil till it's just been pushed out by the force of other droplets from a more recent storm. Perhaps this one fell decades ago, maybe on the very same day I was born in 1978, and percolated down in the groundwater deep below the surface, slowly making its way through the rocks and finally into the river. And of course, these are only a few drops. There are billions and billions and billions of them around the world, in seas, ocean currents, clouds, rivers, lakes, all constantly moving and being buffeted around by the air, the soil, and by people. And while thinking about all these billions of droplets may seem impossible, that's exactly what we ask computers to do to forecast floods. We can imagine the Earth as a giant system and use this to trace the billions and billions of pathways of water. So here's one way that we can see into the future. We use some of the most powerful computers ever made. Some of the world's biggest computers and best forecasts are made here in the UK at the Met Office and at the European Centre for Medium Range Weather Forecasts, where I'm a research fellow. The forecasters use millions of pieces of data from instruments on the ground, on planes, balloons and satellites. And then they create a picture of where all the water is and what it's doing right now, and where it will be in a day, in a week, or in a fortnight from now. At the European Weather Centre, they have access to a lot of data, 270 petabytes of operational and research data. That's more than 400 billion individual meteorological records. And by combining these records with the power of a supercomputer and the idea of an Earth system, it's possible to make global forecasting models, providing flood forecasts for all the major rivers on Earth. And the other incredible thing is that these supercomputers don't just predict the future once, they do it again and again and again, with each forecast looking slightly different based on the uncertainty around the underlying data. And each of these individual forecasts is put into a group, an ensemble. And just like a musical ensemble, the end result is a beautiful product that is much greater than the sum of its individual members. And by putting all of these different individual forecasts together into a group, forecasters can see how certain they can be in forecasting different elements. They can know how sure they can be about where and when and how hard the rain is falling, and can combine this with the uncertainty and complexity of the landscape to say not only what the most likely flood scenario is, but what the worst case could be. And while it may be most likely that the flood will just be a small one, covering just a few fields, it tells you if there's a chance, even a small chance, that it will be roaring through the streets, causing a danger to life. And the amazing thing is we can do this all over the globe now. So for example, let's zoom into Mozambique. The coast of Mozambique is regularly battered by tropical cyclones. What do I mean by tropical cyclones? Well, here in the Northern Hemisphere, around the Atlantic, tropical cyclones are better known as hurricanes, which is what they're called when they hit America. In Africa, they're called cyclones, although they're essentially exactly the same thing. The most powerful storms in the world, hundreds of kilometers across, and causing strong winds, storm surge from the sea, and heavy, heavy rain that leads to flooding. The warm waters of the Indian Ocean fuel these storms as water droplets continuously evaporate and build up the swirling clouds and the structure of the storm. In March 2019, a huge tropical cyclone called Idai hit Mozambique. And then just a few weeks later, another huge tropical cyclone called Kenneth slammed into the country. Hundreds of thousands of people were in immediate danger. I worked as part of a team using our global flood forecasts to help provide information to the UK government and humanitarian partners such as the Mozambique Red Cross. We analysed the tropical cyclone track forecasts, looking at where and when the cyclone might make landfall, but also where it might be dumping all the rainfall it was bringing with it. Really importantly, we could say where and when flooding was likely to occur and where most people were at risk. Providing this early warning means that actions can be taken to prepare for the devastating impacts of huge floods before they happen, rather than just dealing with them after they've happened. People can be evacuated. Rescuers and equipment can be moved to the right place and put on standby. Lives can be saved. I'm often asked about climate change and how climate change might be making floods worse. As the climate has changed, there's more heat and more energy in the oceans and the atmosphere. And more heat in the Earth system means that clouds can hold on to more water, which causes heavier, more intense rainfall. And because sea levels are rising, the flooding is more intense than it would be without the climate change. Climate change makes extremes of weather more extreme than we are used to. It's a complicated picture and not one that we understand fully. In the past, scientists like me have hesitated to say that climate change causes a particular flood to happen because rivers and land have flooded since before humans existed. But we can now say with increasing certainty that you can see human fingerprints in the form of climate change and its impacts on our planet, on many of the floods around the world. And what is very clear is that we need to be much better prepared for more intense and more frequent flood events in the future. To me, rivers will always be beautiful monsters made up of billions of precious blue pebbles. But we now know a little more about them, and by tracing the path of these little blue pebbles across the face of the whole earth, across land and sea and sky, through the billions of different pathways, from the clouds, through the soil, over your rooftops, down the rivers, we've radically changed our understanding of water in nature. And we now have the ability to provide early warnings for devastating floods. So next time you look at a river, take a moment to stop. Go beyond the mass of swirling before you. Zoom in, look for those blue pebbles and ask yourself, where did they all come from? When did they all come from? Where are they all going to?